one last method that we're going to discuss for this assignment is by using one of the special products that we learned about in multiplication of polynomials, and that is the difference of squares. So remember that a plus b times a minus b equals a squared minus b squared. This is one of the special products formula that I asked you to remember from last assignment, and we're now going to make use of it. And making use of it is actually very simple. Anytime you see anything that looks like a difference of two squares, when you have a perfect square minus a perfect square, you should factor it into this form, a plus b times a minus b. Let me remind you, when what we mean perfect square is a result of a whole number being squared. So for example, since 1 squared equals 1, 2 squared equals 4, 3 squared equals 9, so on and so forth, these numbers 1, 4, 9, going on further, these numbers are called perfect squares. Now, if you don't recognize a number as a perfect square, well, then you can't use the difference of squares formula to factor it. Now, you may ask, okay, so what perfect squares should I memorize? My advice to you, memorize your perfect squares at least from 1 to 15. And you probably already know from 1 to 12 because it's part of the multiplication table. So really, it's just knowing that 13 squared is 169, 14 squared is 196, and 15 squared is 225. Ideally, you really want to know from 1 to 20, which would also include knowing that 16 squared is 256, 17 squared is 289, 18 squared is 324, 19 squared is 361, and 20 squared, of course, is 400. Especially if you're still in high school and you're planning to take your SATs, this is fairly useful information for that and other standardized tests. They like to throw stuff at you that uses this knowledge. So definitely know up to 15, ideally up to 20, but I understand if you are reluctant to go that high. So let's take a look at how this works. Let's say that we want to factor y squared minus 25. Well, y squared minus 25 is clearly a difference of two perfect squares because, well, y squared is obviously the quantity y squared, and 25 is clearly 5 squared. So in the formula, a squared minus b squared, it equals a plus b times a minus b. Your a and b are y and 5. And so your answer is just y plus 5 times y minus 5. And just following the formula. Let's do one more example. 16m squared minus 49n squared. Again, these are two perfect squares because 16m squared is 4m raised to the second power, while 49n squared is 7n raised to the second power, right? Those are the a and b of our equation, or our expression, I should say. And so our answer is 4m plus 7n times 4m minus 7n. We're just using the difference of squares formula.